Hi students, welcome to my YouTube channel SADHIK Physics. So you can learn physics very easily through my YouTube channel now, right? So we started recently ray optics now. So in the previous video I discussed reflection due to reflection through the plane mirrors now, right? So now we will discuss in the ray optics now reflection of light through spherical mirrors, right? You might have seen spherical mirrors, no, like a side view mirror of your car, there is like a spherical mirror onto this one. No? If you are crossing right in hill stations, no, if you are having a large turn, no, there will be a convex type of mirrors are used onto this. If you visit a dentist, no, therefore dentist are seeing your teeth, no, with certain mirror, so that mirror is nothing but a concave mirror now. So slightly certain useful uses are there, no. So we will discuss about this spherical mirrors, no, in this today's video, no, right. We will cover all the concepts, no, which are related to this, and we will try to discuss as much as different model type of questions, no. Clear? So you can learn the physics very easily. So when you are seeing this my videos, no, please take down notes, no. So whatever I am writing, therefore you can copy it, no. You can just listen like a classroom, no, right. So now let us start discussing regarding the spherical mirrors now, right. So now what is a spherical mirror now? Plane mirror, you might have seen a plane mirror in your you are seeing in front of your, if you are standing in front of the mirror, that mirror is said to be like a plane mirror now. But here there is a spherical mirrors are there now. We will discuss regarding the spherical mirrors. So first of all, how these spherical mirrors are made up of? You have to take one a hollow, one glass, one sphere onto this one, no. So you try to cut it, these some small parts onto this one, no. You take this part, no. You take this part, therefore this piece, remove the remaining part of this. So you try to do the like a silver coating onto this one, no, right. If you see any mirrors, no, backside there is a some coating is done, that you can call it as like a silver coating is done here, no. So this side silver coating is done, this side is a refracting surface is there, no. So here, so sorry, reflecting surface, here silver coating is done, therefore this side it will be a reflecting surface is there now. Clear? Now if a light rays are coming and falling onto this one, no, if a light rays are coming and falling onto this, a parallel beam of light rays, this parallel beam of light rays are converges to one point, no, therefore that's why these mirrors are called as like a converging mirrors, converging mirror. You understand, no? Suppose if any light, therefore this side it will be a rays are coming and falling onto this one, no. So what will happen now? After reflection, no, therefore it will go back onto this one, no. So these are looking like a diverging light, diverging the rays now. That's why you can call it as diverging mirror. Understand, no? Converging mirror and diverging mirrors onto this, right. So because of due to this shape, no, therefore we can write it as like a concave mirror, and this we can write it as like a convex mirror. You understand, no? So this we can call it as like a concave mirror, and this type of mirror is said to be like a convex mirror now. Clear? So to study about these mirrors, no, therefore we should know some small points, right, some points related to this one, no. Let us discuss what are this. So now let us take one mirror, no. So concave mirror, no. Suppose this is your concave mirror. Clear? So this side it will be your silver coating is done. Now what happened now? So here if light rays are coming and falling, a parallel beam of light rays are coming and converges to one point, therefore this is one point, no. So this we can call it as like a principal focus, and the center of this mirror is there, no. This we can call it as like a pole of the mirror, no. So if you draw one straight line joining this focus and pole, no, this we will call it as like a principal axis, principal axis. Clear? So that means if a parallel beam of light rays are coming and falling, therefore definitely it is going to converge to this point, we will call it as like a you can call it as like a principal focus now, right? So the distance between these two, this focus and pole, we will call it as like a focal length, And if you extend this one now, if you extend this, it will form like a one sphere of this one now. For this one now, there will be a center will be there. We will call it as like a center of curvature. Clear? And from the center to this pole now, we will call it as like a radius of curvature onto this. Clear? So what is this one now? So the distance between the center to this pole, we will call it as like a radius. See, obviously it is like a sphere now. For this one now, there is a radius onto this. So we can have some relations onto this one now. Therefore focal length and this radius of curvature now. Focal length will be equal to half of the radius of curvature. Keep in mind this one now. So these derivations no. So if you really want, I'll discuss as like a separate video for the derivations onto this, right? So right now we'll go for like a competitive exam level no. So now, so this is your center of curvature no, right? Center of curvature and radius of curvature and focus onto this. Okay, clear? Right now, therefore here what is going to happen now? Therefore, it is going to create certain images onto this now, where we can keep the objects now. So one object, therefore one object you can keep it at infinity, right? So another object you can keep between the center of curvature to infinity, in between these one now. So third position is on center of curvature, fourth position is in between these two, center of curvature and focus, fifth position on focus, sixth position focus and pole. Clear? In between this one, like that 6 positions we can make we can place the object, we can form like a different images for a concave mirror onto this. Clear? So first let us go for here, right, to draw the ray diagrams now. To draw the ray diagrams now, we have to follow certain rules to draw the ray diagrams now. What are the rules to draw the ray diagrams, right? So now first of all, let us go for like a rules to draw ray diagram. What are the rules to draw the ray diagram? Suppose this is your concave mirror. So what will happen now? So here this is your principal axis onto this one now. So therefore, if any light ray is there, so which is traveling parallel to the principal axis, if any light ray which is parallel to the principal axis, after reflection definitely it will goes to the principal focus now. If any light ray, so which is passing parallel to the principal axis, therefore after reflection definitely it will goes to the principal focus now. This is one rule. So reverse of this one now also you can take it now. If any light ray which is passing through the principal focus, after reflection it will goes parallel to the principal axis after reflection. Clear? This is second one now. So third one, very important now. Suppose this is your center of curvature now. So if any light ray which is passing through the center of curvature, so after reflection definitely it will go back to in the same direction onto this one now. Clear? So if a light ray is passing through the center of curvature, so definitely why it will rebound back now? Because if passing through the center of curvature means definitely it is going to incident perpendicular to this point. If a light ray is falling perpendicularly, definitely it will rebound back. So therefore, if a light ray is going like this, definitely it will get reflected back and it will go back into the same position onto this, right? So these are the 3 rules you have to follow to draw the ray diagrams now. This is for concave mirror no, and so let us draw for convex mirror also. Now let us see, this is your convex mirror. So therefore this is your suppose here no, therefore now this is your principal axis no. Suppose if any light ray which is coming and parallel to the principal axis, therefore it will be get reflected back, and this reflected light ray appears to be coming from this focus onto this. Clear? Right? So if any light ray which is passing parallel to the principal axis, after reflection definitely it appears to be going from the principal focus onto this. Clear? Next one, suppose if any light ray so which is going on incident onto this one now, and it is getting reflected back, that means this light ray is coming from coming from center of curvature now. Clear? If any light ray, so which is going like this and incidenting onto this now, rebounding back means what? This light ray appears to be coming from where? From the center of curvature onto this. Clear? Right? So like this, therefore, suppose if any light ray, so which is appears to be falling on the principal focus now, like you can see it now. Suppose if any light ray, so is appears to be falling along the principal focus now, that means after reflection it will go so parallel to the principal axis. These are the three rules no you have to follow to draw the ray diagrams. One more rule is also is there no, that is you can take it as this one no. So what is this rule no? Suppose if any light ray is incident at the pole, right, so with the same angle no, it is getting reflected back. This is however loss of reflection now. Clear? So if any light ray which is incident no, this angle alpha and this angle is also alpha. Therefore this also it will be one of the rule you can use it for draw the ray diagrams. Clear? Now let us draw the ray diagrams no. So for this concave mirror and convex mirror no. Clear? So first let us go for concave mirror no. Right? So this is your concave mirror ray diagrams. Ray diagram. So suppose if this is one concave mirror is there no, therefore here there are two positions are there. What are the positions no? Focus and center of curvature. So first we draw no, therefore if any light rays are coming from infinity, definitely after that, so suppose, so the light rays are coming parallel to this one. That means these light rays are coming from parallel means object is at where it is then no? Object is at infinity. So where it is there no? Object is at infinity. So that's why light rays are coming parallel to this. After reflection no, definitely it will goes to the principal focus. So therefore how the image it is there no? How the image is there? Image, this real light rays are coming and meeting onto this one no, therefore it is a real image. You understand? So real, so based on this right, we cannot able to tell clearly whether it is right inverted or real, inverted or erect no. So but it is formed at a focus. Clear? So that means if an object is at infinity, therefore image will be formed at a focus onto this one, right? So actually if you really see that no, there will be a inverted image, it will be formed onto this real inverted, and it is become smaller size no, that's why you can call it as like a diminished onto this. Clear? So therefore real inverted, so diminished and formed at the focus. This is actually the image, right? Now let us draw one more ray diagram no. So for this, suppose this is your concave mirror, right? Suppose this is your light rays no, right, and this is your principal axis no. So this is your right. So if an object is kept where the object is there no, object is at beyond C, beyond center of curvature no, right, beyond center of curvature. This is an object. If any light ray which is going parallel to the principal axis no, what will happen now? After reflection, therefore it will goes to the principal focus. Clear? Now, so what will happen now? Suppose here if a light rays are going to the center of curvature no, therefore this is incident no, this is getting reflected back. So these two are meeting at this point no, therefore this it will be your image. So that means if an object is beyond the center of curvature, so therefore where the image it will be created no, image is created in between this one no, these real light rays are coming and meeting on this one no, therefore this is real, so inverted means this is head is on the top, so head is on the bottom, inverted. So how it is that this is a big size, this is a smaller size, so therefore definitely diminished, right, real, inverted and diminished. So where it is formed between C and F. Clear? You understand no? So this is your image formation onto this one. Clear? So when an object is at beyond C. Clear? Next one. Suppose if a object is kept at center of curvature now. This is your concave mirror. So therefore here this is your center of curvature now. Where the object is kept now? Object is kept on C. Therefore, where the object is there now? Object is on C, on center of curvature now. So, suppose if a light ray is going like this, parallel to this one now, then after reflection no, after reflection, therefore it will goes to the, therefore after reflection it is goes to the principal focus onto this. Clear? Now next one more ray no, therefore if a light ray is going on to the principal focus no, therefore after reflection it will right. So after reflection no, therefore here after reflection, therefore here there is a image is created. This is your object, this is your image. Clear? So that means what you can write it now, therefore here it will be real light rays are coming and meeting, therefore it is a real image, real image. How it is there now? Inverted image, real inverted. So how much amount of size is there? That much amount of size it is there no. So size of right, same size of object no, same size of object again formed on C. These are the right. So one more ray diagram no. Clear? Now what we will do? So till what discuss first infinity, beyond C, on C. Now it in between this one. So what will happen now? Suppose if a light ray, right, this is your principal axis no. So here this is your C and this is your F. So if an object is kept in between, right, in between F and C, where is the object is there now? Object is between F and C. Clear? Now what will happen now? If a light rays are going and parallel to the principal axis no, after reflection, so therefore definitely it will goes to the principal focus now. Clear? Now therefore here one more there no, one more is there. So suppose here if a light ray is going like this, right, so now you can draw it one more thing no, therefore here it is going like this now, therefore here you can take it no. So after reflection it will goes to this one. So that means here, so here how it is there now, therefore here is the object is smaller but image is larger now. This is your image. Where it is found now? Beyond C now. Therefore here what is there now? Here also therefore it is a real image, and how it is there now? Inverted, that is enlarged. Enlarged means what? Magnified. I think these all are you studied in lower classes no, but quick revision no. So if you are really right, so you know this one, just you can skip forward, you can go for fast forward on. Clear? But remembering this image no, formation is very very important. Suppose here there is a, where now where we are keep now, we are keep this one now, object is on focus, right. So now where is the object is there now? Object is at focus. So now what will happen now? If a light ray is going parallel to this one now, then after reflection it will goes like this. Now next one, if a light ray so is going like this, is incident like this, it will get reflected back, therefore it will forming through the center of curvature. This is a parallel beam, so therefore it will goes to infinity. Clear? So therefore here where the image is created no, therefore image is at formed at infinity. Clear? So real, inverted and magnified. If you really go to this one no, real, inverted and magnified image it will be formed, but we cannot go to that. So but here. Clear? So parallel beam cannot form like a image onto this one, because there is no intersection here now. If you go to infinity, therefore it will be the intersection may be possible. Clear? Now this point is most important. This ray diagram is very very important. No, right? Suppose if a object is there now, object is where it is kept now, this is your focus, object is in between the, where the object is there now, object is in between focus and optic center, I mean pole, clear? So where is the object is there now, object is in between, so focus and pole. Therefore here light rays are going parallel to this one now, after reflection, so it is going like this, clear? Next one, so if a light ray, therefore now you can take it as this also, you can draw this diagram also. Suppose if a light ray is incident, therefore here it will be going, if these light rays are coming and falling on your eyes now, right? So therefore what will happen now, these light rays are appears to be coming from here. Coming from here. This is your image, this is your object, clear? But really these light rays are not these are not real, no, these light rays are appears to be coming from here. So that's why this we can call it as like a virtual image. You are understanding? How it is there now? Upright. Therefore here it is head is on the top, head is on the top. That means we can call it as like a erect. And how it is there now? This is smaller, this is bigger. So therefore magnified, that is nothing but enlarged. Clear? So but how it is there now? Erect and virtual image and magnified. That's why this mirror, this concave mirror is used by dentist to see the maximum or magnified image onto this, clear? So this is the position where the object should be kept, no, object should be kept in between the focus and optic, I mean pole of this mirror onto this, clear? Now for concave mirror there is no much more ray diagrams are there, no, only one position you can keep it, no, therefore, right, this is your concave mirror, so this is your principal axis, no, anywhere you can keep, no, therefore suppose if an object is kept here, no, any object, no, so therefore if a light rays are going anywhere, no need of center of curvature, all this one, no. So going like this, therefore this will get reflected back, these light rays appears to be coming from focus here, no. And another one more light ray is there, no, therefore if a light ray is going like this incident, no, then if it is getting reflected back, therefore it is coming from center of curvature. This is nothing but a, I mean this is nothing but a image, this is nothing but a object. How the image is there? These light rays are appears to be coming from, so this is falling on your eyes, no, these light rays are appears to be coming from here, this is nothing but a virtual image. Next one is what, how it is there now? Erect, that is nothing but a upright is there now only. So but here how it is there now? Diminished, therefore it is become like a smaller size now. And if an object is at infinity, therefore the image will be formed at focus, that's all. These are the two ray diagrams, no. So you can go for convex mirror, clear? I'll one tell you, I will just like I will review onto this one, no, how the images it will be there. Listen carefully. For a concave, no, how the images will be there. Just till now, if you right, so if you know it, no, but this time these things, no, you need to remember compulsory, clear? So let us see now. Therefore here listen carefully. If an object is at infinity, where the image is created? Image is created at this point, see here. Infinity at this point. If an object is coming from infinity to this point, so therefore image will go slightly bigger onto this, and that means it will go from focus to optic center, center of curvature. So therefore here what will happen now? If an object is at infinity, focus, no, if it is coming from there, from infinity to beyond C, so the image will be slightly grows and it will comes to here. But as long as it is here, no, the image is smaller now. Once it is comes to the center of curvature, the same amount of image it will be created now. Therefore same size of this. Therefore magnification will be equal to 1. But if the object is, once it is moved into this one, no, the image will go very bigger size. Clear? The image will go bigger size. Therefore, if an object is comes to here, image will go bigger size, magnified image it will be there. So, as it is object goes from here to here, the image will goes from here to infinity. You understand, no? Therefore, if an object go from C to F, so the image will go from C to infinity. Once it is comes to focus, object image is at infinity. So, once it is crossed in this, therefore, in this one, image it will be created onto this. Like this, if you really remember, there will be no problem for this ray diagrams, and you can remember very easily. Clear? Now, we will go for a mirror formula for this one. Let us see. What is this mirror formula? Mirror formula, right? So, you might have see so many, therefore, here suppose here there is a one mirror is there, no? So, suppose here there is an object is there, no? This is your object distance, no? So, definitely therefore, image it will be created here. This is your image, this is your object. So, this is your object distance, no? And this is your image distance, no? This is your focal length. Clear? No? So, you can have the relation onto this one, no? So, how you can write it now? The mirror formula, I am not going to derive it, no? So, you can remember this. So, 1 by F, it will be equal to 1 by V plus 1 by U. Clear? So, 1 by F, it will be equal to 1 by V plus 1 by U. So, you know that focal length it will be equal to half of the radius of curvature. Clear? This is one formula, this is one formula. And magnification, what is the magnification now? So, that is nothing but a height of the image by height of the object, right? Height of the image by height of the object, that it will be equal to minus V by U. Or you can rewrite it as F by F minus U or F minus V by F. These all are the magnification formulas. Clear? So, magnification, what is the formula? Height of the image by height of the object, V by U, F by F minus U or F minus V by F. These are the magnification formulas, no? And this is no, and this one. No. So, to use these formulas, compulsory you have to follow the sign conventions. So, what are the sign conventions? You have to follow certain distances onto this one. No? So, for this one, no, right, you have to follow some sign conventions. For this one, don't remember anything, don't memorize, no, just remember that one point only or 2 points only you can remember. So, this is your pole is there, no, at this pole, therefore, you can make it as like a origin, no, this pole you can make it like a origin. That means this side is positive, this side is positive, this side is negative, this side is negative. So, that means this is pole is at the origin, no, right. So, you might know that in your graph, no, therefore, all the distances will be measured from the origin only. Clear? So, if you are measuring from this, right, this side, no, you have to take positive value. If you are measuring from here to this side, so negative value. If you are measuring from here to upward, positive value. If it is measuring from here to here, negative value. So, in this one only you can tell, no, can you tell me what is the radius of curvature of this concave lens, no, sorry, concave mirror, no. Radius of curvature for concave can be taken as negative. Focal length is what? Negative. Object distance is what? Object distance is nothing but negative. Here suppose this image distance is what? Image distance is negative. Height of the object is how much now? Height of the object is positive. And height of the image is what? Height of the image is negative in this diagram. Sometimes it will be the different values. So, like this, right? So, you need to remember that therefore, you have to take this origin as your pole as an origin, no? Then this side distances are negative, this side distance positive, this side distance positive, this side distance negative, that is all. You have to follow always these rules. No? So, one more rule is that mostly we will keep the object is on the left side, that is why object distance will be taken as negative. Clear? So, for convex mirror, no, therefore, focal length will be positive, R will be positive, object distance will be negative, image distance will be positive. Clear? See here. So, suppose here this concave mirror, no, this side it is there, no. So, therefore, it is a radius of curvature. So, R will be positive, focal length it will be positive, object distance is negative, image distance is positive, height of the object is positive, height of the image is positive, like this, height of the image, above, right. So, like this you have to remember these sign conventions to use these formulas. So, without sign conventions you cannot use these formulas compulsory you have to follow the sign conventions compulsory, clear. So, there is some other magnifications also is there, like a longitudinal magnification, that means always we are keeping the object like this. So, pencil type of object like vertically, image it will be also like this. Suppose if you are keeping the object is like this horizontally, therefore image is also it will be like this. At that time change in length we have to calculate it, you can calculate the magnification. So, here only length only not then, therefore one small area if you take it, therefore it will be bigger area it will be found, there aerial image we have to calculate it, right. So, that type of questions also is there, we will use that, clear. And also velocity of the image you can calculate it, therefore how to do that as a questions in that questions time, there at that point only I will discuss all these applications onto this. I think you got the basic clarity. I think you learned this one now in lower classes, so it's like a just one recalling of this information, clear. But these all are very very important concepts now, clear. You understand, clear. So, power of the mirror, you can rewrite it as power of your mirror can be written as like a 1 by focal length of this one, So, this is your minus 1 by focal length of this part, minus 1 by f, it is in terms of like a meter, clear. So, power of the mirror is what? Minus 1 by f, right students. We will solve some problems related to the spherical mirrors, but to solve this one, these points are very very important. Sign conventions also slightly important. So, here I think it is visible, right. So, suppose in this video, if the questions are not visible, just try to understand. So, I will be explaining that question, then you can understand the question from that. So, a sun subtends an angle theta radians at the pole of a concave mirror of focal length is f. What will be the diameter of the image formed by the mirror? Means, see here, there is a one right. So, here it will be concave mirror, So, suppose here there is a some image, our sun is there, sun is very far away distance, this is your sun diameter. Suppose this is your sun, that is sun diameter is d. Now, what happens now? Here this light ray, that means this is very far away, almost infinite distance, like that we can take it, Then these light rays will come and fall onto this one, That means it is falling the, right. So, here it is making an angle theta here, Therefore, here also it will get reflected back, with the same angle theta here, Therefore, here there is a image it will be formed, image of the sun, right. This is your diameter of the image of the sun, it will be formed. Where it will be formed now? It will form at the focal length onto this. You understand, no? It will be formed at the focus, clear. So, this is the sun now. So, we want to calculate it, Therefore, here we can see so many things, Therefore, suppose here this is tan theta, we can take it as Therefore, tan theta. So, tan theta is nothing but here diameter of the sun by, therefore, this distance between the sun and earth, nearly 1 astronomical unit, or we will take it as like a distance from the sun. Therefore, this is your distance of sun, this is diameter of sun, real. Now, again this image, therefore, again you can rewrite it as tan theta, it will be equal to. So, therefore, here diameter of the image of the sun, diameter of image of sun divided by, this is nothing but a focal length. and one important tan theta and tan theta both are same, no, therefore you can rewrite it as, therefore this diameter of the sun by, therefore this distance between the sun and earth, no, therefore distance between sun and earth. So it will be equal to diameter of the image of the sun by this one. So like this, right? So like this you can rewrite it, no. But he is asking what diameter of the image of the sun, no. Therefore here tan theta is very smaller, no. Theta is small means what you can write it now. Small means tan theta nearly equal to theta. Theta is equals to diameter of the image of the sun by f, no. Diameter of the image of the sun, it will be theta into f. If theta is given in terms of degrees, no, suppose it is given in terms of degrees, no, you have to convert into radians. But he gave already radians, no, theta into f, it will be your answer after this. Clear? It's a very simple question, no? Clear? Some good information you can get it, no? Here one very important question here, no? This is slightly important one, no? Now find the position of the position and nature of the image. Find out the position and nature of the image. So, but where it is there now, therefore these light rays are coming and falling at this point. That means this is nothing but our object. Here converging light rays. This is the object. Now this light rays, what will happen now? It will get reflected now. Therefore it will be formed like this. It will be the image. You understand no? So here focal length of this concave mirror it is there no. Concave mirror no. So is given. Therefore here object is a 30 centimeter. Here this is a very important point now. Therefore here object distance is what you have to do. You have to consider this is your right origin onto this one now, right. So from here to here it is object distance, here to here is the image distance now. Clear? Therefore here object distance is how much now? Object distance is nothing but this side is there now plus 30 centimeter. So focal length of this one it will be toward this side minus 10 centimeter. So we have to calculate image distance. Clear? Very simple one now. Here most of the times now we have to take actually object distance is negative when object is kept on the left side. But here converging rays are forming here no. Therefore that's why object distance is taken as positive now. Therefore use the mirror formula 1 by V plus 1 by U. So 1 by 10 minus therefore 1 by V. So plus 1 by 30 taken here no. 1 by V is equals to minus 1 by 30 minus 1 by 10. Therefore 3 by 30 minus 4 by 30. Therefore V is equals to minus 30 by 4. So therefore here how much will be 15 and 7.5. V is equals to minus 7.5 centimeter. That means so here this side left side the image is going to form onto this one. Clear? Right. So here it is over this side, this real light rays are coming and forming real image now. So from this point you can understand now. Here for this concave mirror, here virtual image, virtual object no. For virtual object here it is forming like a real image. Clear? So but however concave mirror no, it will form like a real image mostly. Okay. Now we will see one more question no. Yeah. So this is one simple question no. Here is gave the object distance, height of the object no, right, and concave mirror is gave no. Focal length is given. We have to calculate position, nature, size of the object. So here sometimes no, therefore always you need not to follow the formula. But here I can write it directly by using this one. This is what you have to develop the skills now. So what is given now here? So focal length is given as 10 centimeter. Focal length is given as how much now? 10 centimeter. What should be the radius of curvature now? 20 centimeter. So that means here this is a 20 centimeter. That means object where it is kept now? Object is kept at center of curvature. Definitely where the image will be formed now? So image is also will be formed here only. So this is your image. So what should be the height of the image now? Right? So height of the image it will be equal to height of the object no, right? It will be nothing but a 4 centimeter, but it will be downward direction no. So therefore it will be the minus. Clear? Where is object distance, image distance? No, image distance is also nothing but a 20 centimeter minus. How it is there now? A real, inverted and same size. Clear? Real, inverted, magnification is 1. Clear? Magnification actually it will be -1. Clear? So, if not, sir, I don't know, means use the mirror formula, then you can solve it very easily. Clear? Okay. So, you can try by using mirror formula, whether you will get this one or not. No, just check it. Next, here again is asking that find out the position, nature and size of the image of this concave mirror. But here 15 centimeter, so definitely, so see here, this only you have to find it, no, always using this formula and this one. No? This is 15 centimeter means here 15 centimeter, here 30 centimeter. That means where the object is there, no? Where the object is there? Object is there in between the focus and so center of curvature. No? That means where the image will be created, no? Image will be created beyond C. How it will be inverted, enlarged, and that is inverted, real, inverted and magnified. That's all. Like that you have to find it now. Clear? So, if any options are given, you would have calculated directly. But if you want to calculate image distance, that only we have to find it now. Therefore, here focal length it will be equal to how much now? Minus 15 centimeter. Right? Object distance is how much now? Minus 25 centimeter. So, image distance it will be, therefore, we want to calculate it now. So, 1 by f is equals to 1 by v plus 1 by u. So, minus 1 by 15 it will be equal to 1 by v. So, therefore, minus 1 by 25. So, therefore, 1 by v is equals to 1 by 25 minus 1 by 15. Clear? So, therefore, here you can rewrite it as 1 by 5 taken common, no? 1 by 5 minus 1 by 3. Clear? So, therefore, here 1 by 5. So, therefore, minus 2 by 15. Clear? Therefore, v is equals to 5 into 15 divided by 2. Clear? So, therefore, it will be minus 75 by 2. So, 230, I mean 6 means 7. Therefore, nearly 37.5 centimeter minus this side. Clear? So, where the image it will be created now? So, this is 30, 37.5, this is your image. So, how it will be then? We drawn the ray diagrams already. Clear? Okay. So, draw properly. Right, this is your image. Clear? So, we want to calculate height of the image, no? Height of the image you can write it as m is equals to, so height of the image by height of the object is nothing but 3 minus v is how much, no? V minus 75 by 2, u is how much now? Minus 25. Clear? So, height of the image by 3, it will be equal to this minus minus plus, no? 75 by 2 into 25. 25 ones are 25. 5 5s are 5 1 15s are 5 1s are 5 3s are. Therefore, here it will be height of the image it will be equal to, so 3 into 3 by 2, 9 by 2, that is nothing but 4.5. Actually, it is minus. So, therefore, here height of the image it will be equal to minus 4.5 centimeter. This is your real, inverted, magnified. Clear? So, in this way you have to solve the problems for this one. Clear? So, that just now I explained, no? Therefore, that if you really remember, that is more than enough, you can do the questions. Here the same type of question, but it is given as So here you can given as convex mirror onto this. Find the position, nature and all this. What is the focal length here now? Focal length it will be equal to plus 15 centimeter, because this side it will be, this side object distance is how much now? Object distance is minus 15 centimeter. Height of the object is nothing but plus 2 centimeter now. Clear? Plus 2. So use the formula 1 by f is equals to 1 by v plus 1 by u. So 1 by 15 is equals to 1 by v minus 1 by 15. That implies 1 by v is equals to, so therefore it will be 2 by 15. So v is equals to 15 by 2, that is nothing but 7.5 plus. So where the image is created, no, therefore plus, therefore suppose somewhere here, no, therefore 7.5 centimeter it is created. Clear? 7.5 centimeter. Clear? This is your image. Height of the image, no, magnification, height of the image by height of the object minus v by u. Height of the image by height of the object is nothing but 2 plus 2 above, minus image distance is nothing but plus 7.5, 15 by 2 by object distance is nothing but 15 minus this minus plus, no, therefore this 15 and 15 cancel. So this 2 and 2 also cancel. Height of the image it will be equal to 1 centimeter plus 1. So that means what you can write it now? So this side is virtual, erect, diminished. Clear? So formed inside the mirror. Remember that convex mirror, no, will always forms like a virtual image only. Clear? Understood? This one. Now let us see one more question. No? Find out the position of an object placed in front of a concave mirror of focal length 30 centimeter, so that 2 times the magnified image will be formed. Can anybody tell me, therefore, so how many positions you can calculate? Right? If you really know it, no, please pause the video and just give a comment, no. Therefore, here how many positions, no? Most of the students what they will think, no, they will think there only one position, but you can have 2 positions. What are the 2 positions, no? Let us discuss. And also we will draw the ray diagrams also. Clear? No. First one, so here he gave magnification. Magnification is therefore here minus 2 for real image. For real image. Second one, magnification is plus 2 for a virtual image. So you know magnification and object distance. Focal length is given, no. Therefore what is the formula? So magnification it will be equal to f by f minus u. So you can rewrite it as minus 2. Focal length of a concave mirror is nothing but a minus 30 minus by minus 30 minus u. So taken here, no, therefore it will be the 60 minus of minus plus, therefore here it will be plus. So 2u is equals to minus 30. Therefore here it will be 2u is equals to minus 90 taken here, no, u is equals to minus 45 centimeter. That means, so here we can draw the ray diagrams, no, where the magnification is 2 times. Here, so what you will get it now, again the same formula. So it is plus 2, it will be equal to f by minus 30 by minus 30 minus u. So therefore minus 60 minus 2u is equals to minus 30. Taken here, no. So minus 2u is equals to, therefore it will be the 30 plus 60 minus 30, u is equals to minus 15 centimeter. Clear? So this is for virtual image, no, this is for real image. So we will draw the ray diagrams for this one, no. So how this double time it will be created, no. Therefore this is your concave mirror, right. So therefore here this is your focus, no. Therefore here it will be a center of curvature beyond this one, no. So 45. Why? Because focal length is 30 sorry here, no. So therefore here this is this is your 30, this should be compulsory 60, means compulsory here the object should be there. Clear? So therefore here what will happen now? Now the light rays will go like this and it will get reflected back, and the light rays it will get reflected back. So therefore here image it will be the twice of this. So therefore here height of the image is nothing but twice that of your height of the object. Clear? This is one of your ray diagram, no? So here this is for virtual image, no? So here, right? So here where you have to keep it now, therefore here it will be a focus, no? So therefore here it will be the object, no? Therefore here light rays are going now, then it will be going like this, then light rays are going like this, these light rays are appears to be coming from here. This is your height of the object and this is your height of the image. So this is your virtual image, this is for real image. Clear? In this way you have to understand very clearly. So about this. Yeah, I think till now you understood what the spherical mirrors, no? Now we will go for one more question here, no? Find out the position of a object placed in front of a concave mirror of focal length 20 centimeters so that the height of the real image is half of the height of the object. That means height is smaller, means where the object should be there, it should be beyond the center of gravity. See, without using any pen and paper, no, how they will solve very quickly means here this all ray diagrams, no, you should keep it in your mind. That means what is asking now, it should be forms real image means inverted image it will be formed, no. So but height is smaller means compulsory image should be formed between the F and C, but where the object should be there, it's a beyond C. Beyond C means what? Focal length is 20, means center of curvature is 40, therefore above 40. So if any option is there which is above 40, that is your answer, that's all. So no need to solve any type of problem like that, right? I mean by simply substituting and solving, no. Clear? Like this also you have to do it. Clear? For competitive examinations. So what is given now? Therefore your magnification is nothing but so minus half for your real image now. So therefore here height of the image, therefore it will be minus V by U. So that is now you can use it, no, R. So F by F minus U. Therefore minus 1 by 2, F is how much now? Minus 20 minus U. How much it will be now? So taken here, no. So minus or minus plus, no, you can get it as 1 by 2 into 20 plus U is equals to minus 20. Clear? This multiply it, no, this is you can multiply 20 plus U is equals to minus 40. Clear? So U is equals to minus 40 minus 20. So U is equals to minus 60 centimeter. That's what I told you, no, it should be greater than 40. Clear? In this way you can solve the problems. Now I told you, therefore here a thin rod of length, okay, length is there, no, therefore a thin rod of length 10 centimeter lying along the principal axis of the concave mirror of focal length 20 centimeter such that its image which is real and elongated. It's a real means compulsory formed on the same side of this. Just touches one end of the rod. Find out the length of the image. Right. So here what you can write it now? Right. Real elongated. Elongated means it is really larger now. Therefore, here what do you get it now? Listen carefully. We will draw the ray diagram so that you can understand very clearly. So therefore, here this is your focus. This should be your center of curvature. So elongated means what will happen now? Making bigger size. Suppose if the rod was like this, what will happen now? The image it will be the smaller now. But here what is telling now, he told that it is elongated now. Therefore, rod is not like this now, right? So, you can do as one question now. So, if you really want, okay. So, here how the object is there now, object is like this. So, what will be the length of this now? Length is equals to 10 centimeter. Clear? So, that means it is touch x now. Touch x means what? This is your center of curvature. Compulsory, this is your object now. Compulsory, this here is going to touch it now. Clear? And this is an object which will be create like a image here now. Therefore, suppose for this one now, this is 1, it is 1, here 2. So, therefore, image of the 2 it will be like this here. Clear? So, how it will be there now? The image it will be looks like this. Clear? Why? So, when it is here now, therefore, it will create like a elongated. So, this is your length of the object and this it will be the length of the image. We want to calculate it. You understood? You understood? Clear? So, therefore, here in this way you have to calculate it. No? Now, we want to do the question here. No? So, first of all, here for this object, for this it will be the image. Okay. Now, this distance I know it. What is this distance now? This distance, focal length is how much now? Focal length it will be equal to 20 centimeter. Right? This 20 centimeter means this side is 20, this is nothing but a 40 centimeter. This one end I know it. Another end I don't know. So, for this one now, this is your object, this is the image. What is the object distance now? U is equals to, this is 10 centimeter means from here to here 40. Therefore, in the 10 centimeter forward means U is equals to minus 30 centimeter. Clear? So, what will be our focal length now? Focal length is equals to minus 20 centimeter. So, we want to calculate it. So, substitute the formula 1 by F is equals to 1 by V plus 1 by U. So, minus here minus 1 by 20. So, it will be equal to 1 by V minus 1 by 30. Taken here now. 1 by V is equals to 1 by 30 minus 1 by 20. Clear? Therefore, I can make it 60. Therefore, 2 and 3 I can multiply it. No? So, therefore, 1 by V it is 2 minus 3. Therefore, minus 1 by 60. So, that means V is equals to minus 60 centimeter. Clear? So, this distance is how much now? This distance is nothing but a 60 centimeter. Clear? So, what will be the length of the image now? Therefore, length of this one now, the length. So, you can rewrite it as length of the image. You can rewrite it as, therefore, final distance 60 minus 40. Therefore, it will be the 20 centimeter will be your length of the image. In this way, you have to calculate the problems of this one. Clear? Right? So, you can do one question here, no? Same type of question only. Suppose as a work, no? Suppose here this is here, right? Focal length is F is equals to 20 centimeter. So, focal length is 20 centimeter. So, where the object is there now? Here there is your focus. Here there is your center of curvature. So, therefore, here what will happen now? Here there is a length of the object is 10 centimeter, where one of this end is or concentrated onto this one, right? Find length of the image. Clear? And draw the ray diagram for this one, right? So, as a work, no, you can do it. So, still if you don't know, please comment it, no. Therefore, I will try to solve the problem for this. Clear? Now, let us see here one more thing, no. Right. A square of side is there, 4 millimeter is placed at a distance of 30 centimeter from a concave mirror. Concave mirror now. Of focal length 10 centimeter now. The center of the square is the axis of the mirror now, and the plane of the normal, right? Find the area enclosed by the image. Image area of the image now, you have to calculate it now. So, what is this one? Actually, it is given concave mirror, no? There is a one concave mirror is given. Clear? Right? Always depending on the formulas, all this one, no? Slightly, right? Not good. Try to understand the situation, no? So that you can get the idea, that is how to solve the very quickly, you know. Suppose here focal length of this how much, no? 10 centimeter, no. So at certain place, no, there will be there is a square of side 4 mm is given. No. Therefore, height of the object is given as 4 mm. Clear? Height of the object is how much? No, 4 mm. Clear? So which is at a distance is how much? No, distance is nothing but a 30 centimeter, which it will be the distance after this. So 30 centimeter means here what is given now? Focus. 10 centimeter means center of curvature is 20 centimeter beyond C. Beyond C means what will happen now? So image will be smaller. Therefore, height of the image it will be the smaller. Area of the image it will be also smaller onto this one now. Clear? Like this you should get one clarity onto this one now. So first let us calculate. So here somewhere here beyond C it is there, no. Therefore here there will be a somewhere image it will be created. This it will be the image, this it will be the object. You have to calculate the area of the image now. Clear? So first of all let us calculate this height now. Clear? So height of the object. So object distance is given now. Focal length it will be equal to minus 10 centimeter. Object distance is equals to minus 30 centimeter, no. So where it will be the image distance. Therefore 1 by f is equals to 1 by v plus 1 by u. So minus 1 by 10 it will be equal to 1 by v minus 1 by 30. Clear? So 1 by v is equals to 1 by 30 minus 1 by 10. Therefore 3 by 30. So therefore 1 minus 3. Therefore minus 2 by 30. So v is equals to minus 15 centimeter. So therefore the image where it is formed now 15 centimeter. This is the image is formed. Clear? You understand? No? So now we want to calculate height of the image. Right? So therefore here magnification height of the image by height of the object it will be equal to minus v by u. Height of the image by height of the object is nothing but 4 mm. So minus 15 divided by minus 30. Clear? So this will cancel 1 by 2. So 1 and 2. Therefore height of the image is equals to minus 2. Therefore here it will be the minus 2 mm. This is your height of the image. So this image means what? This is the side of this one, no? This also side. So therefore what will be the area of the image now? Area of the image. So it will be equal to, so therefore here it is a square, no? Square means what you will get it now? This one, no? So minus 2 mm into, that's minus is for sign conventions, no? So 2 into 2, therefore 4 mm square will be your area of the image. Clear? Sometimes if you really want to find it, no, so you can use a formula. Therefore here magnification, so you can write down height means height of the image, that means length of the image into, that is aerial magnification, this you can call it as. Therefore breadth of the image by length of the object into breadth of the object. This is their area, that is nothing but area of the image by area of the object. Clear? So that is nothing but the L by this one, no? This is your aerial magnification. So aerial magnification, this is m into m. So therefore it will be m square. That means aerial magnification, so area of the image by area of the object it will be equal to linear magnification square. Clear? This is linear magnification. Clear? In this way also you can use it. Okay? So we can calculate the problems now, right? But I am telling no, therefore in this way if you really learn, therefore you will learn the concept. This is, you can learn the conceptual wise. Clear? Now, okay, find out the velocity of the image. Here both are moving. Object is moving, mirror is also moving. First of all let us see. So therefore what will be the relation between velocity of the object and velocity of the image? What you can write it now? See here. Now 1 by focal length it will be equal to 1 by v plus 1 by u. So do the differentiation now. Constant focal length, no, focal length is 0. So therefore it will be v to the power of minus 1 object distance no. So differentiation no. Okay, you can write it as, or I can rewrite it as focal length to the power of minus 1, object distance to the power of minus 1, image distance and object distance. This is constant, it is 0. So minus 1 into, so minus 1 by v square into dv by dt. This is minus 1 by u square into du by dt. Clear? So du by dt is nothing but a rate of change in the position of a object distance, no? Rate of change in this one, no? Taken toward this side. So therefore 1 by v square into velocity of the image, it will be equal to minus 1 by u square into velocity of the object. So taken here, no? So velocity of image is equals to minus v square by u square into velocity of object. Means v by u whole square we can write down velocity of the image. So this is is equals to minus m square into velocity of the object. These velocities are written with respect to the mirror. That means velocity of the image with respect to mirror, velocity of the object with respect to the mirror. This is your velocity formula. Clear? Right? Velocity of the image with respect to the mirror minus magnification square into velocity of the object with respect to the mirror. Clear? That is nothing but you can write it as relative velocity. So therefore velocity of the image minus velocity of the mirror. This is velocity of the image with respect to the ground, velocity of the mirror with respect to the ground, it will be equal to minus m square into velocity of the object with respect to the ground minus velocity of the mirror with respect to the ground. Clear? So in this way, therefore you can use this formula. Clear? Right? So therefore here we can rewrite it as, therefore here you can use sign conventions here, no? Therefore you can apply here, no? If an object is moving toward this side means it is positive I cap. If any image is moving toward this side, minus I cap. Clear? Now that means what you can understand, velocity of the mirror is plus I, velocity of the object is plus I. Clear? So then what you can rewrite it here now, what is given now? Velocity of the object is 4 centimeters per second, velocity of the object is at distance, object distance is given now. Clear? Okay, let us see, let us go for this one, no? So here there will be object is going, velocity of the object is 4 centimeters per second, no? Which is at a distance of 30 centimeter, no? Clear? From the mirror, right? So this velocity of the mirror is 2 centimeters per second, no? Focal length it will be equal to 20 centimeter. Focal length is 20 centimeter. So now first of all let us calculate the magnification here, no? So what is the magnification? Here we can write down velocity of the image minus velocity of the object, it will be equal to minus m square, sorry, this is your mirror, velocity of the object minus velocity of the mirror. Clear? First calculate the magnification. Magnification is equals to f by f minus u. F is how much now? Minus 20, because focal length of this one is minus, by minus 20. So therefore minus of minus plus 30. Right? So therefore it will be how much now? Minus 20 by 10, therefore minus 2. So will be your magnification now. Clear? No? So velocity of the image we want to calculate it now. Image minus velocity of the mirror is how much now? 2I cap. Clear? So therefore minus magnification is nothing but a minus 2 whole square into velocity of the object is nothing but a 4I cap minus, so velocity of this one no? 2I cap. Clear? So how much now? Velocity of the image minus 2I cap is equals to, therefore this is minus 4 into, therefore this how much now? It is 2I cap, therefore here velocity of the image you can rewrite it as 2I cap minus 8 I cap, it will be equal to therefore minus 6 I cap. Therefore, velocity of the image, it will be equal to minus 6 centimeters per second. Clear? Minus 6 centimeters per second, this it will be the velocity of the image. Clear? Now here one concept is there, one more concept. No, see here, one more doubt it will be there. Suppose here there is a one mirror is there. This is one mirror. Clear? So therefore here there is a light, here there is a principal axis is there. No, suppose here focal length is, suppose it will be 10 centimeter. So therefore here there is an object is there. No, it is going like that. Therefore here object is going with a velocity of 2 centimeters per second now. So which is at a distance of 15 centimeter now. Clear? So here this object now, it is not moving toward this mirror now. It is going like this. So definitely, so what will happen now? Therefore here object distance is not changing now. This object distance is not changing. Therefore here vertical only it is changing onto this one now. Therefore, so here there is no magnification square, it will not be there. No. So here, so you know that velocity of the image with respect to the mirror, velocity of the image with respect to the mirror, it will be equal to minus magnification velocity of the object with respect to the mirror now. Clear? Na? So in this way you have to see it now. If an object is going like this, so definitely it means it will go in this way. Clear? So here you can rewrite it as velocity of the image minus velocity of the mirror is equals to minus magnification velocity of the object minus velocity of the mirror. Clear? Na? So here mirror is not moving, no, therefore velocity of the mirror is 0. So magnification we can calculate, magnification is nothing but f by f minus u. So how much now magnification now? Therefore minus 10 by minus 10, minus of minus plus 15. So therefore m is equals to minus 2. So because it is 5, so 2. Clear? So therefore velocity of the image minus 0. So it will be equal to minus of minus 2. Clear? Velocity of the object is 2 centimeter minus 0. Clear? So how much it will be now? Velocity of the image, so can be taken as like a, this is 4 centimeters per second. In this way, therefore the velocity of the image, it will go in this downward direction with a greater speed onto this. Understood? Huh? So don't confuse on the velocities if an object is moving toward this side, if an object is moving like this onto this. Clear? Very important concept, no? Right? For JEE means this one. Now we will go for some more questions, no? Here. Right. So find out the height of a image formed after second reflection. Consider first reflection on the mirror 1. Therefore, here what are the mirror 1 no? Here mirror 1. This is one mirror no? This is your second mirror no? So what will happen now? Image formed after second reflection now. So therefore, you have to take this is your this is convex type of mirror onto this one no? What will happen now? Light rays, it will come here no? It will go like this. Then it will get reflected back. You understand? No? So therefore here light rays are coming like this, therefore it will get reflected back. That means, so these light rays are coming from here onto this. Therefore this is your image, first image. Clear? This image will act like a object to this one now. Clear? This image will act like an object to this one now. Then another image it will be formed onto this one now. First of all, let us calculate here now. Therefore, this image distance no, we will calculate it now. For first mirror, mirror 1, let us see what is the focal length of this one now. Focal length of this 20 centimeter. Focal length of the first mirror is 20 centimeter. So therefore, height of the image we have to calculate. So therefore, here object distance it is given as like a 30 centimeter no? 30 centimeter, right? So this is your minus. Okay. Suppose let us take this one no? This is your okay, you can use this is your optic center onto this one no? So what will happen now? Okay, this is your object distance. Let us calculate the image distance now. Now, therefore, 1 by f is equals to 1 by v plus 1 by u. So, therefore, 1 by 20 it will be equal to 1 by v minus 1 by 30. Therefore, 1 by v is equals to 1 by 20 plus 1 by 30. So, how much it will be? 60 you have to make it now. This is 3 and 2. So, therefore, 5 by 60, 1 by v is equals to 60 by 5, 12 times. Now, this image is formed at 12 centimeter now, meter from this mirror onto this. So, now this image will act like an object to this one now, right. Therefore, what will be the object distance now? Here 48 plus 12, this is plus 12, how much it will be? Therefore, 60 centimeter now for this. So, what will be our object distance now for mirror 2? So, therefore, here focal length of the mirror 2, it will be equal to 20 centimeter now. What will be our object distance now? Minus 60 centimeter. So, 1 by v, okay, height of this. Right. So, let us see here now. 1 by f is equals to 1 by v plus 1 by u. So, 1 by 20 it will be equal to 1 by v minus 1 by 60. 1 by 20 plus 1 by 60. Clear? So, this I want to make it like a 120. So, this is 6, this is 2. So, 1 by v is equals to 6 plus 2, 8 by 120. V is equals to 120 by 8, 4 2s are 4 30s are 2 1s are 2 15s are. Therefore, image distance is about 15 centimeter plus 15. That means, where the image it will be created now? Somewhere it will be created now. 15 centimeter. Clear? Now, what do we want to calculate now? Here, height of the image now. First of all, this height we want to calculate it now. Right? This height, first of all, first height, what you will get it now? First magnification. So, height of the object, height of the image we want to calculate. Height of the object is how much now? 3 centimeter. So, it will be equal to minus. So, v is how much now? Minus v is equals to, this side it is 12 divided by minus 30. Clear? So, this one this 10 minus get cancelled. Height of the image is equals to 1.2 centimeter. Therefore, this height is about 1.2. Now, this magnification due to m2, so height of the final image, height of the object is how much now? 1.2. It will be equal to minus v. V is how much now? V is nothing but 15 divided by, so u is how much now? U is nothing but 60, minus 60. Clear? So, therefore, here you can cancel it now. Therefore, 15 ones are 15 fours are. Therefore, height of the image is equals to 1.2 divided by 4. So, 12 by 4 no. Therefore, height of the image it will be equal to 0.3 centimeter. This is your final height of the image now. Clear? So, in this way any number of mirrors are there. So, it does not matter on to this. Understand the concept very clearly, then apply, you can get your answers automatically. Now, we will discuss one more question now. Let us see. Here also some more combination of the mirrors. Right. Here again find out the value of x. X we want to calculate such that light rays retrace its path after reflection. Consider first reflection on the mirror 1. Okay. That means light rays are retracing its path. Retracing its path, don't confuse anything now. Therefore, light rays what you have to do? So, what it is retracing means compulsory it has to incident normally, or it's a spherical mirrors means light rays should undergo like a passing through the center of curvature. That's all. Okay. So, this is the one extra point you need to remember. Here very simple one now. Find the value of x. Retrace its path. This is on M1 we have to calculate it now. Therefore, so retrace its path means here this light ray should go like this. Clear? This is your object distance, no? Therefore, then after reflection, after reflection, so it should go like this and it should incident onto this one. That means this is coming from here, somewhere here, no, and it is getting reflected, therefore it should incident here, no. So then it will get reflected back. Clear? Like this. So very simple concept, no. Now you understood, I think. Okay. So if possible, you can try it, no. This is your 15 centimeter. You try to calculate this distance, no. This image distance, no. First mirror, we can calculate for first mirror, no. So focal length of this one is how much now? It is a concave mirror onto this one, no. Minus 10 centimeter, no. Object distance is nothing but a minus 15 centimeter. So use this 1 by f is equals to 1 by v plus 1 by u. So 1 by 10, it will be equal to 1 by v minus 1 by 15. So 1 by v is equals to 1 by 15 minus 1 by 10. Clear? So 30 I can make it now. Therefore 1 by v, this is 2 minus 3 by 30. V is equals to minus 30 centimeter. That means here this distance is how much now? From here to here, this is 30 centimeter. Clear? That means it is incidenting at this point now. Therefore compulsory this has to be compulsory this radius of curvature now. How much radius of curvature now? This focal length is 10 centimeter means radius of curvature of this one now 2 times of f 20 centimeter. This should be compulsory 20 centimeter. Clear? Therefore definitely this is 20 centimeter means what you will get it now? So this is totally 30 centimeter no, and this is 20 centimeter means what you will get it now? Therefore this distance no, so this distance x value is equals to 30 minus 20, therefore it will be 10 centimeter. Okay, this 10 centimeter no, 10 centimeter means it should be lower than this one no. Okay, that means problem is slightly wrong thing is there. Okay, so but here this object cannot be there, but here somewhat it is rays are coming and falling on like that. Okay, so but you should understand the logically onto this one now, how I am solving the problems onto this one now. Clear? Right? Right? We'll see some more questions. No? Right? Completed. No? So okay. Thank you for watching my video. So really if you learn something, no, please subscribe. No? So those who want to learn the physics very easily, please share my video so that others also can learn very easily on this. Clear? So thank you for watching. Please subscribe to my channel. Thank you.